We are meeting once again, Power Machines N5. So today I will try to integrate the following two topics, which is I'm going to start off with steam plant as well as boiler efficiency. So these are the two topics that we are going to start off with today. So before I start off solving any of the questions, let me just try to give you a bit of some formulas which you might need on these two topics. Now, we can start off by our formula for enthalpy of a superheated steam, which we normally refer to it as HSU. Now, the formula which we use to calculate the enthalpy or the energy of superheated steam, we can use HSU equals to Hg plus Cp into Tsu minus our Ts. So this formula is also there on your formula sheet, so there's no need for you to stress much about it. But the most important thing, you will find that our specific heat capacity is our Cp. In some situations, it might not be given. So if it's not given, we use our HSU at, or using the superheated steam tables. I think I will illustrate what I'm trying to say here, but the third option, it occurs in this way. You will find that the pressure that is given might not be on the steam table. So, or the temperature is not given on the steam table. So how do we address such a situation? So we can also solve that problem by means of interpolation. So basically, I think that today we are going to address all these three challenges which I'm putting in place. Now, from our formula HSU, these are the three conditions on how we get our enthalpy of superheated steam. Now the question will be, what does Hg stand for? Now Hg, that's our enthalpy of dry saturated steam. So once again, it is also read, or we get it from the superheated steam table. And then we have our Tsu, which is our superheated temperature. And then we also have the last part, which is our Ts, which is our saturation temperature. So the saturation temperature, which is our Ts, it is also read from the steam table. Now, let's go to the second part. So we have the formulas of how to calculate our enthalpy of superheated steam. Now, the other formulas that we need, we might need formula for calculating enthalpy of wet steam, which is normally referred to as our H-wet or our H3. We'll be explaining much as we go. Now, how do we calculate our H-wet? Enthalpy of wet steam equals to HF plus Q times our HFG. So we can use this formula where our Q you can look at our Q. Some they tend to write it like this. H weight equals to HF plus X times our HFG. So where our X or our Q, it denotes our dryness fraction or dryness factor of steam. In other words, it gives the specific whether it is the quality of steam, wet steam, or it is superheated. And then, remember, most of these values we get them from the superheated or our normal steam table. Now, one thing that we must understand is how to get these values from the steam table. So I think as we go, you will see how we are going to be using our steam table. So another formula that we need is volume of superheated steam. You can say it our VSU or V superheated. So on this one, we have quite a number of formulas, but the conditions of the question they will give you a proper direction on which, so that you'll be able to know which formula you're supposed to choose. So we can start from here. V superheated equals to Q times Vg at whatever given pressure. And we also have V superheated equals to 0.23 into our H superheated minus 1941 over our P1. So these are formulas which we can use to calculate our V superheated, but don't forget we can use the first method, the second method, the third method. If the two conditions are not working well, we can resolve it by means of interpolation. As we are going through, I think you will see a picture of what I'm trying to emphasize. So we have the last part that we need to look at is our enthalpy of dry steam, which is basically our Hg. So Hg, we don't have much stress how we solve our Hg. We just know that Hg is the same thing as Hf plus our HFG. In other words, if you add your sensible heat plus your latent heat, it gives you the enthalpy of dry steam. So I think on this side, on the part of our formulas, we are in. Now to demonstrate whether you are following what I was saying here, let us go to this question which I have given you on this other side. Now, we are given if 10 kgs water at 920 kilopascal, a pressure and a 6 degrees Celsius is not heat, is rather heated to boiling point, then to dry saturated, and then to super heat of 210 degrees Celsius. Determine our sensible heat, that's our A, our B, latent heat, and the number C, the superheat, and our Cp is given, and then last but not least, the total heat required for superheating. And lastly, the saturation temperature. Now, let's look at how we can attend to this problem. We can start off with our A. The question says, determine the sensible heat. So, to determine our sensible heat, our given pressure is given as 920 kilopascal. So we need to go to our steam table, our normal steam table at 920. So at 920, we look for our HF. That's our sensible heat. So our HF, that's our sensible heat. So in other words, we are looking for HF at 920 kilopascal. If I check from the steam table here, I'm getting 747 kilojoules per kg. But don't forget, we are also given the temperature of water, as well as a mass of 10 kgs. Now, so for you to get the total enthalpy here, what we need to do now, we now say, therefore, HF, which is 747 minus our H1 of water. Now, to get our H1 of water, we have a number of formulas which you can use. The easier one is to go directly at 60 degrees Celsius at your steam table. But because I know how to use the steam table very well, if you check, you'll find that on our steam table, we do not have 60 degrees Celsius. On the steam table, we have 60.1. Therefore, you can resolve this by means of interpolation. But under examination conditions, it will waste your time. So the simpler way to get our H1, we say therefore H1 equals to Cp of water times 60 degrees Celsius. That's how we do it. Which becomes Cp of water is constant, is 4,187 times 60 degrees Celsius. We get our H1. So we can go together there, 4,187 times 60. I'm getting 251,22. Therefore, we have 747 minus our H1 of water, which is 251.22. So if you subtract the 2, I'm getting 495.78 kilojoules per kg. But don't forget, our mass is given as 10 kg. So you must multiply this by the given mass. So what are we getting here? This and this, they cancel. So we are going to have times 10. We are going to get our answer as 4957.8 kilojoules. So that becomes our enthalpy of sensible heat. Now, for number B, they want us to determine our latent heat. So I will erase this side so that we can do that question.